SS Physics, Female, Test by Kppsc 2023 with full explanation. Question 1. The energy of moving electron is A. Continuous, B. Discrete, C. Non-continuous, D. Abrupt. The energy levels of electrons in an atom are discrete and quantized. When an electron transitions from one energy level to another, it absorbs or emits energy in the form of photons with specific frequencies or wavelengths, which correspond to the energy difference between the two levels. Question 2. Neutron is converted into proton, electron, antineutrino, the radioactive process called A. Alpha decay, B. Beta decay, C. Gamma decay, D. None. In beta decay, a neutron within the nucleus of an atom is converted into a proton, which changes the identity of the atom to a different element. In the process, an electron and an antineutrino are emitted from the nucleus. The electron is known as a beta particle, and the antineutrino is a particle with no electric charge and very little mass. Question 3. In constructive interference, path difference is A. 1 wavelength, B. 1/2 wavelength, C. 1/4 wavelength, D. None. In constructive interference, the path difference between two waves must be an integer multiple of the wavelength, lambda, of the waves. This is because when two waves are in phase, their crests and troughs line up, they add together to create a larger amplitude wave. So, in constructive interference, the path difference is equal to an integer multiple of the wavelength, or path difference equals m lambda, where m equals 0, 1, 2, 3. Question 4. Special theory of relativity applied to A. Inertial frame of reference, B. Non-inertial, C. Both, D. None. The special theory of relativity applies to inertial frames of reference. An inertial frame of reference is a reference frame in which a body that is not subjected to any external forces moves with a constant velocity or remains at rest. In other words, an inertial frame is a non-accelerating frame of reference. Question 5. The capacitance of parallel plate capacitor directly proportional to if D is separation. A. A by D, B. A by B, C. A by D square, D. A by B square. The capacitance of a parallel plate capacitor is directly proportional to the area of the plates, A, and inversely proportional to the distance, D, between them. The relationship between capacitance, C, plate area, A, and distance, D, can be expressed as C equals epsilon, A by D. Question 6. If metal sphere is placed on insulated stand and a positive charged rod strike, what will happen? A. Gain proton, B. Gain electron, C. Lose electron, D. Gain proton and lose electron. When a positively charged rod is brought near a metal sphere placed on an insulated stand, the electrons in the metal sphere will be attracted to the rod due to the electric field. As a result, some of the electrons will move from the sphere to the rod, leaving the sphere with a net positive charge. Question 7. Division and Germer experiment show that charged particle, electron, has A. Wave nature, B. Particle nature, C. Dual nature, D. None. The Davis and Germer experiment is a classic experiment in physics that demonstrated the wave nature of electrons. In this experiment, a beam of electrons was directed towards a crystal and the resulting diffraction pattern was observed. The diffraction pattern exhibited interference fringes, similar to those observed in the double-slit experiment for waves, suggesting that the electrons had a wave-like nature. Question 8. If amount of element is 24 gram, its half-life is 1 month, how much is left after 2 months? A. 1.6 gram, B. 3 gram, 5 gram, D. 6 gram. Initially, the amount of the element is 24 gram. After 1 month, the amount remaining will be 12 gm, half of 24 gram. After 2 months, another month has passed, the amount remaining will be 6 gm, half of 12 gm. Therefore, after 2 months, the amount of the element remaining will be 6 gram. Question 9. If 2 hockey puck of unequal masses is attached to spring, if spring is released, then center of mass of hockey puck move in the direction of A. At rest, B. Moving in direction of large mass, C. Towards similar, D. None. When 2 hockey pucks of unequal masses are attached to a spring and released, the center of mass of the system will move in the direction of the larger mass. This is because the spring exerts a force on each puck, which is proportional to the displacement of the pucks from their equilibrium positions. Since the force on each puck is proportional to the mass of the puck and the larger puck has a greater mass, it will experience a smaller acceleration than the smaller puck. As a result, the center of mass of the system will move in the direction of the larger mass. Question 10. Quarks are basically of how many colors? A. 1, B. 2, C. 3, D. 5. Quarks have 3 types of color charges, red, green, and blue. These color charges are a property of quarks in the theory of quantum chromodynamics, QCD, which is the theory that describes the strong nuclear force that binds quarks together to form protons and neutrons. It's important to note that the colors of quarks have nothing to do with actual colors that we see in the visible spectrum. It is simply a label used to describe the different properties of quarks. Wave associated with a moving electron is A. Plasma waves, B. M wave, C. Gamma waves, D. Matter waves. The wave associated with a moving electron is called a matter wave or a de Broglie wave, named after French physicist Louis de Broglie. Plasma waves are waves that propagate in plasma, which is a state of matter consisting of ionized gas. M waves are electromagnetic waves, such as radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Gamma waves are a type of electromagnetic radiation with the highest frequency and shortest wavelength in the electromagnetic spectrum. Question 12. Galvanometer change to voltmeter. It will be connected to A. Low resistance R in series, B. High R resistance in series, C. Low resistance R in parallel, D. High resistance R in parallel. When a galvanometer is converted to a voltmeter, it is done by connecting a high resistance in series with the galvanometer. This high resistance is known as a multiplier resistor and is used to limit the current through the galvanometer to prevent it from getting damaged due to excessive current. Question 13. Water is warmed up from 0 degrees Celsius to 6 degrees Celsius. It will A. Expand steadily, B. Contract steadily, C. Contract then expand, D. Expand then contract. This means that the volume of water will initially decrease, contract, as it is heated from 0 degrees Celsius to 4 degrees Celsius, and then increase, expand, as it is heated from 4 degrees Celsius to 6 degrees Celsius. This behavior is due to the fact that the density of water is highest at 4 degrees Celsius, and as the temperature deviates from this value, the density of water changes accordingly. Question 14. The energy released by photon is A. Quantized, B. Discontinuous, C. Continuous, D. Packets. The energy released by a photon is discrete and quantized. The energy levels of electrons in an atom are discrete and quantized. When an electron transitions from one energy level to another, it absorbs or emits energy in the form of photons with specific frequencies or wavelengths, which correspond to the energy difference between the two levels. Question 15. In special theory of relativity, length and time are A. Constant, B. Absolute, C. Relative, D. None. In the special theory of relativity, length and time are not absolute, but are instead relative and dependent on the observer's frame of reference. This is one of the fundamental principles of the theory. In the special theory of relativity, length and time are not constant or absolute, but are relative and dependent on the observer's frame of reference. Question 19. When two quantities are inverse proportional, its graph will be straight, parabolic, hyperbolic, straight to the axis. When two quantities are inversely proportional, their graph will be a hyperbola. A hyperbola is a type of curve that resembles two curves that are mirror images of each other and are separated by an asymptote. The equation for an inverse proportionality is y equals k/x, where k is a constant of proportionality. Question 20. Force on gluon is gravitational, strong nuclear force, weak nuclear force, none. The force on a gluon is the strong nuclear force. Gluons are the elementary particles that mediate the strong force, one of nature's four fundamental forces. The strong force is responsible for binding quarks together to form protons and neutrons, and it is also responsible for binding protons and neutrons together to form the nuclei of atoms. The other three fundamental forces are the electromagnetic force, the weak nuclear force, and the gravitational force. Question 21. Neutrino belongs to leptons, mesons, photons, quarks. Neutrinos belong to the class of subatomic particles called leptons. Leptons are elementary particles that do not interact via the strong nuclear force, and include particles such as electrons, muons, and tau particles, as well as their associated neutrinos. Question 22. Find magnetic force when I and B are parallel. The magnetic force on a current-carrying wire is given by the formula F equals BIL sine theta. When I and B are parallel, the angle theta between them is 0 degrees, and sine theta equals 0. Therefore, the magnetic force on the wire is 0. Question 23. Find magnetic force. I and B are perpendicular. The magnetic force on a current-carrying wire is given by the formula F equals BIL sine theta. When I and B are perpendicular, the angle theta between them is 90 degrees, and sine 90 equals 1. Therefore, the magnetic force on the wire is given by F equals BIL. Question 24. Lorentz transformation postulates shows V greater than C, V much smaller than C, V less than or equal to C, V equal to C. If an observer's velocity, v, is greater than the speed of light, c, it violates the second postulate and is not possible. If an observer's velocity, v, is much smaller than the speed of light, c, then the effects of special relativity are negligible and classical mechanics can be used to describe the observer's motion. If an observer's velocity, v, is less than or equal to the speed of light, c, then the effects of special relativity become significant, and the observer's measurements of space and time will be different from those of a stationary observer. An observer cannot have a velocity equal to the speed of light, v equals c, according to the laws of physics, as it would require an infinite amount of energy to accelerate an object with mass to the speed of light. Question 25. Einstein theory postulate shows v equal to c, v greater than c, v less than c, v comparable to c. If an observer's velocity, v, is equal to the speed of light, c, it violates the laws of physics and is not possible for an object with mass to reach the speed of light. If an observer's velocity, v, is greater than the speed of light, c, it also violates the laws of physics and is not possible for an object with mass to travel faster than the speed of light. If an observer's velocity, v, is less than the speed of light, c, then it is possible for an object with mass to travel at this speed or slower. If an observer's velocity, v, is comparable to the speed of light, c, then the effects of special relativity become significant and the observer's measurements of space and time will be different from those of a stationary observer. Therefore, the correct statement among the options is v less than c.